This is the Golden Gate, a mile of freezing, violent water. They said crossing it was impossible. But in 1920, San Francisco was dying, trapped on a peninsula, completely choked by the sea. To go north, you risked your life on packed, rusty ferries through blinding Pacific fog. The best engineers alive looked at this water and called a bridge suicide. And honestly, they were right. It acts like a giant funnel. The entire Pacific Ocean crushes through a tiny gap, creating lethal riptides. But Joseph Strauss didn't care. He was a dreamer with a huge ego, and he wanted the job. The Navy fought him hard. They feared a bombed bridge would trap their entire Pacific fleet. Then the Great Depression hit. Men were starving in the streets. The city desperately needed jobs. Against all odds, they found the money. In 1933, the ultimate suicide mission finally broke ground. Building the North Tower was a breeze. The bedrock was sitting right there on the dry beach. But the South Tower was a nightmare. To make the math work, they had to build it in the open ocean, 100 feet down, freezing temperatures, and currents so vicious they could tear a diver's air hose. Just to reach the site, workers had to hammer a fragile wooden pier straight into the Pacific, and nature immediately fought back. The legendary fog rolled in, dropping visibility to absolute zero. A lost cargo freighter, blinded by the weather, plowed straight through the pier. Weeks of labor gone. They rebuilt it. But months later, a freak storm hit, washing millions of dollars of equipment out to sea. Imagine the toll on these guys. You fight the freezing ocean for months, and it just erases your work in an hour. To build the tower, they needed dry land, so they decided to build a giant concrete bathtub. They dropped steel guide tubes to the ocean floor, but the bedrock was a jagged, sloping mountain. To flatten the rock 100 feet down, they had to drill and blast, dropping time bombs into the dark. The currents here are deadly. Divers could only drop down during slack tide. A tiny 20-minute window. Imagine sinking into pitch-black water, wearing 200 pounds of brass and lead. The clock is ticking. They descended into the gloom, feeling their way blindly along the jagged rock with heavy explosives. Working entirely by touch, they shoved dynamite deep into the bedrock. If the tide shifted early, they died. They pulled the divers up, hit the plunger, and shattered the ocean floor over and over again. Slowly, brutally, they carved a perfectly flat plateau directly into the underwater mountain. With the floor leveled, they lowered the steel skeleton of the bathtub. It was the size of a stadium. Then came the pour. Using special funnels, they pumped millions of pounds of concrete to seal the bottom. Once the plug cured, they threw the pumps into reverse, sucking millions of gallons of seawater out of the tub. Look at this. I am standing 100 feet below sea level in the Pacific Ocean, and my boots are dry. Inside this dry pocket, they poured the true foundation. A solid concrete island rising above the waves. The ocean threw everything it had at them, but human grit won. The base was finally set. But concrete is just the anchor. To cross a mile of water, they needed custom-forged steel, 83,000 tons of it, loaded onto ships and hauled thousands of miles through the Panama Canal. Every piece was coated in a bright red lead primer to fight off the vicious saltwater rust. The barges finally arrived at the gate. The brutal underwar was over, but the danger was just beginning. Next, we build a steel tower taller than a 6-story skyscraper by hand in the fog. The men are heading into the clouds. Whatever you do, don't look down. The foundation was poured. Now, 83,000 tons of red steel had to climb into the clouds. These towers aren't solid blocks of metal. They are built entirely out of hollow steel cells. A solid tower would snap in an earthquake. This honeycomb design lets it physically bend and twist without breaking. But how do you lift steel 700 feet up? You invent a machine that climbs the building, the creeper crane. It hauled massive steel sections straight up from the rocking barges below. When the crane finished a section, Heavy hydraulic jacks pushed the entire rig higher up the tower. But the crane just places the steel. It takes the rivet gangs to lock it together forever. Step 1. The heater bakes a solid iron rivet in a tiny forge, suspended hundreds of feet in the air. Step 2. He throws the glowing molten iron directly across the open void right through the freezing wind. Step 3. The catcher snatches the lethal hot metal out of the air using nothing but a tin cup. Step 4. They smash the hot iron with a pneumatic gun. As it cools, it shrinks, pulling the steel tight. I'm standing on an 8-in beam 500 feet up. No safety nets, no harnesses. One slip, and you're gone. These men were doing the highest stakes physical labor on Earth. Up here, they looked like ballet dancers. The biggest enemy wasn't the height. It was the wind. Sudden gusts constantly tried to throw them into the sea. They had to wrestle massive steel plates into place while the Pacific gales fought them every single inch. But they weren't just building a functional support column. They were building an architectural masterpiece. Architect Irving Morrow designed the towers to look like massive Art Deco doorways to the Pacific Ocean. He added massive vertical grooves to catch the light and shaped the cross bracing into a triumphant portal. Inside the legs, it was a dark, echoing maze. Workers climbed hundreds of feet of narrow ladders in the pitch black. Finally, after months of brutal high-altitude warfare, the tower reached its peak, 746 feet above the water. At the very top, they lowered the saddles, massive grooved blocks of steel that will hold the weight of the bridge. These saddles weigh hundreds of tons, but they aren't bolted down tight. They actually sit on massive steel rollers. When the sun hits the cables, the steel expands. These rollers let the saddle shift, preventing the tower from ripping apart. With both colossal towers finally standing, the massive empty gap between them was painfully obvious. The gap was 4,200 feet, the longest single span ever attempted by the human race. Before they could hang a bridge, they had to build the anchors, massive dead weights buried deep in the shore. They buried gigantic steel hooks directly into solid bedrock and poured thousands of tons of concrete over them. A suspension bridge actively tries to rip itself apart. These anchors have to resist 50 million pounds of pulling force. To span the gap, they started with a single tiny wire, hauled slowly across the violent water by a small boat. Once connected, massive steam winches hauled that first wire out of the water and high into the sky. From that single wire, they hung a pair of terrifying swaying wooden catwalks across the entire mile-long gap. The catwalks swung wildly in the brutal wind. For the men working up there, the nightmare was just beginning. The main cables weighed 24,000 tons. You cannot physically lift something that heavy into the sky. So, if you can't lift the massive cable, you have to completely manufacture it wire by wire in mid-air. Welcome to the spinning wheel, the most brilliant piece of bridge-building technology ever invented. The wheel travels back and forth across the entire gap, laying down a single strand of wire every trip, back and forth, day and night. They are about to spin the most massive web of steel in human history. John Roebling invented this spinning tech decades ago, but Strauss had to scale it to an impossible size. To beat the punishing schedule, they built a dual-wheel carriage. It pulled 2 steel loops at once. Heavy carriages launched from both shores simultaneously. They crossed in dead center midair, like a terrifying mechanical ballet. As the heavy wheel flew past, iron workers called comrades had to wrestle the fast-moving steel by hand. If a single wire tangled or lost tension, an alarm screamed. The entire colossal machine stopped dead. Listen to that. Every single wire had to have the exact same tension. One loose wire and the bridge fails. The timeline was absolutely brutal. The wheels ran 24 hours a day, slicing through the freezing fog. If you laid the wire from just one main cable, end to end, it would wrap around the Earth 3 times. After 6 brutal months, the raw material was ready. 61 separate bundles of pure high-tensile steel. Now for the brute force. Massive hydraulic jacks violently squeezed the chaotic bundles into a perfect tight circle. Immediately behind the jack, a wrapping machine spun a tight skin of wire to seal the cable from salt air. The result? A massive, completely solid 3/4 thick artery of pure steel, the lifeline of the structure. This massive cable has to support its own crushing weight, plus the entire road, and still survive a hurricane. To hang the road, they violently bolted massive steel cable bands around the main artery at exact intervals. From these bands, they aggressively dropped the vertical suspender ropes. These are the actual lifelines for the road. With the suspenders hanging loose, the barges returned. It was time to violently haul the steel floor into the sky. Workers dangling in the void violently hammered massive steel pins through the joints, locking the heavy floor in place. You can't just build from one side to the other. The terrifying weight would instantly pull the towers out of balance. It's a high-stakes seesaw. Every time they hang a steel section, they must perfectly balance it on the opposite side. Beneath the floor, they built a highly complex steel truss network. This wasn't just for cars. It was for the wind. Bridges don't just sway. They can violently twist and tear themselves apart if the aerodynamics are wrong. To stop the bridge from twisting to death, Strauss engineered this massive stiffening truss. It acts completely like a rigid spine. Slowly, agonizingly, the two massive halves of the heavy steel roadway crept toward each other in the dead center. November 1936. The final massive 10-foot gap remained. The entire colossal structure hung entirely in the balance. The massive cables completely expand in the heat. To fit the final beam, they literally had to completely wait for the exact temperature. When the temperature was perfect, the massive crane dropped the final steel beam. The gap was finally closed. For the first time in human history, you could physically walk across the violent Golden Gate Strait entirely on steel. With the steel locked, they violently poured the thick concrete driving surface, adding millions of pounds of dead weight. As the crushing weight of the concrete was added, the giant cables stretched and settled entirely into their final curve. To stop the corrosive salt air, every single inch of steel had to be aggressively coated in a toxic red lead primer. The U.S. Navy demanded the bridge be painted in violent black and yellow warning stripes like a giant bumblebee. But the architect looked at the raw red primer against the deep blue water and realized the Navy was completely wrong. He fought to keep the primer color. He called it International Orange. Highly visible in the fog and visually stunning, the massive structure was almost finished. But the brutal, violent reality of 1930s construction was about to collect its toll. The brutal, accepted industry math at the time was entirely terrifying. 1 dead man for every million spent. This was a highly dangerous $35 million project. The brutal expectation was that 35 men were guaranteed to die, but Chief Engineer Strauss refused to accept that violent math. He became entirely obsessed with safety. In the finale, Strauss installs the most brilliant safety net in history. But even that violently fails to stop the ultimate tragedy. Strauss mandated safety gear. He modified heavy mining helmets, entirely inventing the modern hard hat. He aggressively fired men for showboating. He demanded special glare goggles and forced workers to heavily tie off their tools. But his most brilliant move was this. He spent over $130,000 on a circus-style safety net. The net was a massive financial gamble. It extended 10 feet out on both sides to catch anyone blown off the steel. The massive net absolutely worked. It safely caught exactly 19 men who violently fell from the massive steel. Those lucky 19 survivors formed a highly exclusive fraternity. They proudly called themselves the Halfway to Hell Club. For nearly 4 brutal years, Strauss defied the bloody math. But on February 17, 1937, the massive structure violently fought back. Subscribe my channel, Next Gen Manufacturing. Hit the bell for new mega projects. Thank you. Bye-bye.